So a question like this is slightly more involved, but involves the same identities that we've been dealing with. What we know for sure is that sine A is 5 over 13. The other thing we know is that A is between 90 and 180, otherwise known as quadrant 2. That information is going to be important a little bit later on. We know cosine of B is negative 15 over 17, and B is between 180 and 270, otherwise known as quadrant 3. And again, important information later on. Question 1, we have to find sine of A plus B. And in order to do that, we need the right side of that equation. So the right side of sine A plus B is sine A cos B plus cos A sine B. So there's 4 things we have to know. Sine A and cos B we do know. Cos A and sine B we don't. So before we get to actually figuring out what this is, we need to figure out what is cos A and what is sine B. So to figure out cos A, the only piece of information we can use to find this is sine A. Because if we try to use cos B that's dealing with a different angle, we have to deal with the same angle. So we have to only use sine A. So looking back at the fundamental identities to do this, we have an equation that relates cosine with sine, and that's sine squared plus cos squared equals 1. Sine is 5 over 13. Cosine, don't yet know. And now it's just a matter of solving out this equation. Oops, forgot 5 over 13 squared. That's kind of important. So 5 over 13 squared is 25 over 169. I'm going to change the 1 into 169 over 169. Subtract the 25 over 169 over, so we get cos squared A equals 144 over 169. Square root both sides, keeping in mind we need plus or minus. And we get that cos A, if we take the square root, plus or minus 12 over 13. This is where the quadrant 2 piece of information comes in. If we draw out the quadrants and we look at cast, quadrant 2 is S, meaning sine alone is positive, so that would mean that cosine is actually going to be negative 12 over 13. We're just going to hold on to that for a minute because we still need to find sine B. We'll go through the same process that we just did. Except this time, instead of A's, we'll use B's. We don't know sine B. Cos B is negative 15 over 17. And do the math to solve for sine B. Subtract the 225 over 289. We get sine squared B equals 64 over 289. Square root, plus or minus. And so sine B equals plus or minus 8 over 17. To To determine whether it is plus or minus, take a look back. B, as you can see, is in quadrant 3. Quadrant 3 being t, so tangent is positive, meaning that sine B is negative 8 over 17. So all of that information that we've just found has just been to actually go to the sine A plus B equation, which, again, is sine A cos B plus cos A sine B. At this point, now we can plug things straight in. So sine A was 5 over 13. Cos B, negative 15 over 17. Cos A, which we calculated on the last slide, was negative 12 over 13. Sine B, which is just to the left, negative 8 over 17. Do the math. 5 times negative 15, negative 75, over 13 times 17 is 221. We've got negative 12 times negative 8, so that will be plus 96 over 221. And we have a common denominator built in. Add the tops, we get 21 over 221. Now, looking to reduce this is usually a good option, but with these types of questions, the final answer will usually be unreducible, so don't look too hard. This was just question A, sorry, question 1. Question 2, a little bit easier to deal with since we've actually done a bunch of the legwork for it in question B, or in question A, sorry. So we need to find cosine of A minus B. We'll look at the formula sheet. That is cos A cos B plus sine A sine B. We have all 4 pieces of information, so we can just go and plug in. Cos A being negative 12 over 13. Cos B, negative 15 over 17. Sine A, 5 over 13. Sine B, negative 8 over 17. Multiply each fraction, negative 12 times negative 15, 180. 13 times 17, 221. 5 times negative 8 is negative 40 over 221 again. Common denominator is built in, so subtract, we get 140 over 221.